Section 1.3, definitions of the 6 trig functions. At this point, you should remember that you have the sine, cosine, and tangent from geometry class. The sine, by definition, is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And so, by using SOHCAHTOA, it's a shortcut in solving for the trig functions of a certain angle. There's a lot of information for this section, and it's important to know pretty much all of it because these are the basis points of trigonometry. And if you know it so-so, it's always going to occur that you're going to have problems with the questions later on. So now we're at a point where we want to master the topics, we want to learn them, memorize some stuff, and be comfortable with it going forward. In this first diagram, you're going to see that there are pluses and minuses. Pluses refer to the positive direction of the x. So this is positive to the right, this would be positive up. This would be a point here where it's negative, negative, would be like -2, -3. And so that's what that is all about. Also, you have the degrees, 0, 90, 180, and 270. So we know where to draw an angle in standard form. And then you have some letters up here, A, S, T, and C. And those letters indicate where the trig functions are positive or negative. That's what this is all about right here. The positive trig function is in bold, and that means all are positive. This means just the sine and cosecant are positive. This means just the tangent and cotangent are positive. And this means just the cosine and the secant are positive. That will mean more later on, but just know these letters, A, S, T, C, represent the positive trig functions in those particular quadrants. Also remember, you have quadrants, 1, 2, 3, and 4. Shifting to this other side, we're going to use this drawing quite often, and if you had a point x, y, and an angle theta, you're going to see that you have an x coordinate, you have a y coordinate, and you have an r, and r is going to be the distance from the origin to the point. Since distances are always positive, your r is always going to be positive. X and y could be positive or negative, r is always going to be positive. Moving ahead, we're going to define all 6 trig functions. So if you're wondering what this cosecant is all about, we're going to talk about that right now. At this point, you know sine, cosine, and tangent, and the SOHCAHTOA that follows from it. Notice that you have the sine of an angle. I'm not saying sine times an angle, I'm saying the sine of an angle. This cannot be separated. It is one unit. Some students will think that it's times throughout the whole trig section and get confused on the algebra. It has to stay the same, sine theta. Don't drop the theta, keep it with the trig function. We all write it as the sine of theta, it's pronounced the same. And we're now going to remember O over H, but it also means in this coordinate plane, it's Y over R. Why? Because you're looking at this Y and this R. Opposite over hypotenuse, Y over R. Looking at this one, it becomes the cosine, X, which is the adjacent, over R, which is your hypotenuse. So we're just tagging X, Y's, and R's with opposite adjacents and hypotenuses. Tangent, O over A, Y over X. What do you have to remember? Memorize at this point that your Y's go with your sine, and your x's go with your cosine. Commit that to memory. R's remain the same, you just want to remember that so you don't have to do this memorization and going back to that diagram. And then the tangent would be y over x. Now, the second set of trig functions are the cosecant, secant, and cotangent written below. I wrote them this way because they're reciprocal functions of what's up above them. For example, sine and cosecant are reciprocal functions because by definition, the cosecant is r over y, which is the reciprocal of y over r. Every time I want to find the 6 trig functions, I want to write them this way so I don't have to think as much. I want to put the cosecant under the sine and just do the reciprocal. I want to put secant over cosine, so I just have to do the reciprocal. Make the thinking easy so you can concentrate on other stuff. How do I remember that? Well, you're going to see that the s's and the c's go together, the sine, cosecant. Same thing here. S's and c's go together, cosine and secant. That's how you know they're reciprocals. That's how you can remember it. And then what's left? Tangent and cotangent. In your homework, you're going to have to identify the 6 trig functions of a certain angle, and so you're going to want to write them like this. Furthermore, let's take a look at this example. And this example is going to have an angle, theta. And the angle theta is going to have a point on it, which is -4, 3. And the point is on the terminal side of the angle. And so what we're going to do is first draw this and see what it looks like. And I'm going to tell you this all the time, draw the object. Look at it on paper, put as much information on that paper as you can so you're not doing things in your head. That's going to be the majority of mistakes, is making things, doing too much in your head. I draw this, I put theta here, I'm looking at this point. I know that my y is going to be 3 and my x is going to be -4. What is the first thing that I need to solve for in order to fill out my 6 trig functions? There's a missing element in this problem. The answer should be 5. It's kind of like I'm doing this Diego or Dora, yeah, Dora the Explorer, where she goes, what's the color of the dinosaur?
It's right there, Dora.
Right, it's purple. So, I don't know if that's going to continue, probably not very good idea. Anyway, we have 3, -4, the correct answer is we need the hypotenuse, 3, 4, 5 triangle. That's a Pythagorean triple. If you remember it, you don't have to do the Pythagorean theorem. Now, we're going to go over here and we're going to see that the sine of theta is equal to my y over r by definition, which means that this answer is going to be my y over my r. What you could do is just say, you know what, x equals -4, y equals 3, my r is equal to 5. And I could just substitute those right into here, so this is just going to be 3 over 5. Cosine. Cosine of theta goes with x. X over r. My x is -4, my r is 5. Tangent. Tangent is y over x. I look over here and it's going to be 3 over -4. Tangent theta equals -3 over 4. If I write this correctly, cosecant theta, secant theta, cotangent theta, I'm pretty much done. I just have to do reciprocals. So this becomes 5 over 3, -5 over 4, negative 4 over 3. Done. Don't do shortcuts in your writing. Make sure you're including your theta. Make sure you're including the equal sign. Look at this question. Find 6 trig functions of theta if 0, negative 2 is a point on the terminal side. What's the first thing we're going to do? Draw it. Good. So we're going to draw it, and it's going to be 0, negative 2, which is a point right down here. X is equal to 0. Y is equal to negative 2. R is equal to 2 because it's the distance from the origin to the point. Notice, I'm not drawing a triangle. I am just drawing a point on the axis. There's 2 different ways of doing this. If it's not on the axis, you draw in a triangle. If it is on the axis, you just draw the point and figure out your distance, which is it could be the absolute value of that number, like negative 2. Good. I'm going to write them in the same order as what I wrote before. Sine, cosine, theta, tangent, theta, cosecant, theta, secant, theta, cotangent, theta. My goal is to do the top 3 and then just flip them for the other 3. Sine theta is going to be, again, y over r. I go over here, it's going to be negative 2 over 2, which is equal to a negative 1. Cosine theta, 0 over 2 because it's x over r. What number times 2 gets you 0? 0 times 2 gets you 0. The other way you can't do it. That's why it's undefined. Let's take a look at tangent theta. Tangent theta y over x, which equals negative 2 over 0, means it's undefined. Undefined is a term. It's not a number. It's not equal to it. It's just the tangent of theta is undefined. Now we just flip for the reciprocals. I can go up here and say, oh, this is going to be 2 over negative 2 when I switch it, so this is going to end up as still negative 1. Or I can say negative 1 over 1, flip it, you still get negative 1. Secant is going to be undefined. Why is it undefined? Because 0 over 2 is 2 over 0, which means that it's undefined. So I'm actually going up to here to help you with that. And this one is going to be 0 over negative 2, which is now 0. Looking in your book, I'm checking problems like 27 through 32. Let's take a look at a problem like 32 that says negative 90. And let's say, what is the cosine of negative 90? Let's just identify this one little part of it. First thing I'm going to do is draw it. I'm going to be very clear on the drawing. And this is going to be a point, which is like 0, negative 1. You have your x, you have your y, and then you have your r, which is 1. The problem that we had at the beginning of class is what's the cosine of 90. Now we can solve this problem. Even though this is negative 90, it's the same idea. I get my x, my y, my r. Cosine is the same thing as x over r. X is equal to cosine. And therefore, it's just going to be 0 over 1, which is equal to 0. Cosine of negative 90 is 0. For that reason, you could also do the same thing up above as and you'd get 0 as well, because it would be 0 over 1 as well. Good. One other idea is, let's think about this first concept, and I'm looking at quadrant 1, 2, 3, and 4. Your answer to my questions now are going to be either quadrant 1, 2, 3, or 4. And so if I say something like, okay, which quadrant is the sine theta positive and the cosine theta positive? The answer would be quadrant 1, because all of the trig functions are positive. What about this? What's the quadrant where the tangent is positive, tangent theta positive, and the cosine theta negative? Tangent theta positive is going to be either the first or the third quadrant, but the other one negative is going to be in the third quadrant, so I would say quadrant 3. What's the quadrant where the tangent is negative and the cosine is positive? Cosine of positive is going to be here because of that C, and the other one is negative, so that would be quadrant 4.